saying something controversial. There we go.
I think it was when Ken stepped out, they stopped the recording because he started it, but now we are back.
Good.
So, Chip, you're going to talk about you were going to talk about some circuit board stuff you were doing. Was that right?
Yeah. I've going through the same stuff you've been going through. Although decidedly lower cost and trying to keep it simple and affordable.
We started off with that goal.
Yeah. 6-layer boards.
6 layers, 100 parts. Yeah.
Yeah. Well, okay, so what I've been doing, let's see, can I share? How do I do this? Share. I'll just share my screen. Okay, well, let me switch over to the layout. Can you guys see this?
Yeah.
Okay, so I've been working with Doug at Doco Engineering. He used to work at Parallax and he uses propeller chips for stuff, and he's doing a lot of automation, like automation control systems and doing custom machinery for people making medical devices and window frames and door frames and all kinds of robotic stuff. So he wants some kind of like controller of his own to be able to use, and he likes propeller chips, so he's having me design a propeller board, and it's got like 24 sets of 24-volt digital IOs, and then it's got 8 10-volt analog IOs and 4 of these IO link connectors, and then 8 clear path motor connectors. And I've done all this motion control software that's working great. So we want to put all this into the P2, and then we have 2 Ethernet connectors on there too, so that we can have it take commands from a PLC, but then you could also write code for cogs that actually take over the PLC job and then work through the memory interface that the PLC is basically dealing with. It's like a register in, register out kind of thing. It's very simple. So anyway, this board's going to be kind of big, and we want to stay away from making it too expensive. So I've been laying out all the pieces of it. There's lots of sub blocks that are replicated, and then I've got down to the P2. I've got the switchers done, but the P2 is like of significant interest because the P2 actually can dictate a lot of things about your circuit board because of the way the pins are arranged. I mean, it's simple in a sense, but it's kind of, you've got to come up with a method to deal with these power pins. So it's very like well grounded and well powered, the chip is. So that's probably also why I can run real fast. Okay, let me go to my top layer here, and oh no, let's see. I've got some. Let me try to move the share window over here so it's out of the way. All right. Okay, so you can see if anyone's ever looked at the P2 pinout, we have 2 IO pins, and then they're surrounded by well, in the middle of 4 IO pins, you have a VIO pin, which powers those 4 pins. On the die, there are down bonds that go down to the ground pad on the bottom, which also dissipates the heat. And so where we have this VIO, there's also an adjacent ground pad that drops down and picks up ground. So you have a little ground and a 3.3-volt source for these 4 IOs right here. And then we have in between every set of these 5 pins, which are really 6 bonds because of the hidden ground, we have a 1.8-volt pin, right? And that is what powers the core. So anyway, we have to get all this stuff connected. We want to keep the net super low impedance, especially like, ground, of course, is ultimately low impedance because it's one big pad on the bottom of the chip. And I don't know how many, like, let's see, there's so many down bonds to ground. It's crazy. I guess we probably got 64 of those on the chip. Or no, we have 32 down bonds to ground. That's right. There's 8 per side of the chip, 8 per edge of the chip. So we need to control the core. The core is just one voltage, it goes around. But for IOs, we might want to be able to isolate in order to come up with separate regulators for doing quiet analog stuff. in this design here, all of these, I had to disconnect a bunch of stuff because I'm in the process of figuring out the formula for making this happen. But I've got it working on the bottom row, but not complete on the sides and top. But basically, over the top of the chip, the north, east, and west sides are going to be powered by one 3.3 volt source. And then we have separate sources for these 8 pins and these 8 pins. So I think these are DACs and these are going to be ADCs. So aside from this matter of, having decoupling, let me turn on the thing so we can see the parts here. Top component out. Oh, no, not that. I'm just kind of new to using this software myself. So there we have the component outlines. Let me make them brighter so they stand out more. Okay, so you can see we have the crystal down here. We have all these little, I started off with 0603 caps because I didn't want it, Doug doesn't want things to get too small because he wants it to be workable and, not requiring too fancy of a pick and place to do, but I did go to 0402s. But this board is built on 6-on-6. So it's 6 mil trace, 6 mil space, which is not an exotic process. It's not the run-of-the-mill cheapy either, but it's kind of simple. I don't think it's too expensive. And then this is a 4-layer board, right? So we started off thinking we're going to have 6, and I thought, no, we can do it in 4. But then I realized with 4-layer boards, you have constraints. You can either have buried vias like between the inner layers, inner 1 and inner 2, or vias that go through the whole stack from top to bottom and they pass through inner 1 and inner 2. You can't, I was thinking that with 4 layers, we can do vias from 1 to 2. That's what I need. I need to get these IO pins out of here and spread them around, but it doesn't work that way. So we're going to go for like the cheap 4-layer board, just through vias, no buried blind vias or anything, just vias from top to bottom. And we're using a 12 mil drill. That's the smallest, and then that we're going to use. And then we have a 6 mil annular ring for make a 24 mil via pad. And we have some covered vias like for the 1.8 volts. But here's the thing. So after we worry about all this business, we have to make sure that all of this effort is not frustrated, right? All this matter of handling this heat pad, we've got to be able to get the heat out to the bottom layer, and it has to be able to spread out. So that means uninterrupted copper. But we can't have totally uninterrupted copper because there's just too darn many things that have to be brought out and go away. So we have all these IO pins, right? Here's 2 IO pins, here's 2 IO pins, here's another 2 IO pins. So if my first thought was, well, I'll put all of the vias on the inside ring for the IO pins and clean them up. And so this and this would be over by these 2. But you can see what happens when you get to the bottom layer. Now let's go look at the bottom layer. Let's see, bottom this, and then I got to select bottom here. So here's the bottom layer, right? Okay, there. So that's what it looks like. We have the bottom layer is nothing but a big ground plane. So had I put the IO pins, these guys up near here, you can see that it would have effectively thermally isolated that area that the heat comes down. Now on the P2 edge, that's a 6-layer board. So it's just pure covered ground via. That's all that's coming out of the bottom. I don't even know if there's an exception to that. On the earlier boards, we had a couple just, vias with some.
You guys froze up.
Are you guys still there? My internet.
Oh man, it's freezing here because everyone's frozen.
You're unfrozen, Chip. Yeah, it froze for about, I don't know, 10, 15 seconds.
Oh, okay. All right. Yeah, I'm in the house. It's not as good as out in the shop. So you can still hear me now, right?
Yeah.
Okay. So you see now the heat has a way, right? So it comes down through all these vias, hits this bottom layer, which will be probably like a 4-ounce copper layer. And then I minimized the size of these interruptions, right? So this via is an IO pin. This is an IO pin. This is the 1.8 volt core. But because it's okay to have a via there, because it doesn't make, what we don't want to do is constrict these channels of solid copper, right? Because that's where the heat's going to spread out. It's these vias will do nothing. They're isolated. They're not going to convey the heat, but this copper piece here will. So we need to keep, uninterrupted sections of copper as much as we can going out. So it's good to have minimally what you can up near the chip inside the pad ring. And then down here, these would be better on the bottom if they were like vertically aligned, but we can't do that because of constraints on the top. So if we go back and look at the top again, we can see that there's just, when I bring out, I don't have room to put these things vertically and get escapement for this power. This is the IO power right here. So what this means is this board should keep the chip pretty cool because there's sufficient copper. And it's not an expensive process. It's only through vias. There's no blind buried thing. So it's as cheap as a 4-mil board can get, or excuse me, a 4-layer board, that is 6-on-6 without any tiny drills or anything. These are all, as I said, 10-mil drills. I think I'm in metric mode at the moment here, but anyway, now okay, you see this thing here. Let me turn on this. Let's see, where do I get it? Where's the 1.8 volt? Right here. Do I have any routing? There we go. Okay, if I hit this there, that's the 1.8 volt copper on the top layer, right? And you can see there's like 16 vias that stitch it downward, and they're not creating any heat disturbance because they're still permitting the channels to go on the bottom layer out. So if we go to the inner one layer, this is what we have. So here are those stitch vias that attach to the top 1.8 volt ring. And then I have a nice big fat copper area here that I can bring my 1.8 volt supply into right up in here. And so that's going to make it easy. Now, the last thing is we have to have escapement for the IO pins, right? Because they need to get out and go to their places. So we go to inner 2. I just did a little mock-up thing where I showed that, here we go. Here are 4 IO lines. These are on the outside of the pad ring. These are on the inside of the pad ring. And there's the 1.8 volt via. And then this is a ground. That's actually at the bottom, a buried ground via. And then this is a supply for the IO. So on the top layer, I can actually run a strap across these things and just tie those powers together. So I think I've met all the objectives, and I've tried to do this as cheap as possible. But this recipe can be followed by anyone who wants to make a board where, this is not the tightest way to lay out this thing, but if you're cost sensitive and you've got a big board, I mean, this board's going to be probably 8 inches across by maybe 4 inches tall or so. It's going to be pretty big. So we got room. We're not real tight about, not like what Lachlan just showed us. That's another deal.
You said you're going to do buried vias?
No buried vias, only through vias, because the buried vias cost more.
Yeah, I tried. I couldn't find anybody that would make them for me. So yeah.
Yeah, just through vias. Keep it simple and cheap and flexible. Then you can go to different places more easily. So see, at each of the inner layers, we copy the heat. The vias, of course, are coming down, and then we put a big copper plane there to again help push the heat. But really, when we get to the bottom, that's when we have the big heat spreader. This is what's really going to spread the heat.
That looks like a lot more vias on the ground pad than we normally see. That's
the edge has like some crazy. It's like an 18 by 18 array.
Oh, is that what this is?
And this is 16 by 16. No, this is 17 by 17. I
Okay.
went to a metric grid because I could not get sensible repetition using mills. I had to go down to half a mil and it was all jiggly and things jogging around. So I finally just go, okay, make the origin for my work purpose right now, the middle of the chip, and then all of the IO pins on the top come out in sensible, nice integral positions. So then I can position all my vias on a I think this is like a 30, maybe a 16th of a millimeter. That's what my grid is. But see, the package is metric, so that works out fine. These pins are on a half millimeter pitch.
Yeah, so is it generally accepted that more smaller holes for the ground pad is better than less big but bigger
Well,
vias?
I don't know. I think Michael said, he said, forget micro vias being heat pipes. They're not going to work. You need something substantial. So this is like, these things are 10 mil holes. Let's see. Well, let me, what does it say there? 0.61 millimeters. No, 0.305 millimeters on the hole on the drill. So you don't want them too small because they won't drive the heat down, and you don't want them too big because then when you squeegee this solder paste on way through the vias and make a mess. So 10 mils has been found to be about right. That's what Michael said because he's done a lot of iterations of this.
Hey, Chip, I got a question about your stack up there.
Yes.
So this is a 4-layer board?
Yeah, let's see. Is there a stack thing here? How do I do this? I just started using this thing. Let's see. Route manual. There's a thing. Where do we set up the stack? It's basically just 4 layers. And the way this is fabricated is an inner circuit board, an inner double-sided circuit board is made, right? Just 2 sides. Then they do 2 very, very thin single-sided boards that they put out with the copper outward facing. They sandwich that all together. Then they drill and plate the holes.
Okay, and so it looks like you have the entering there looks like it's your core 1.8 volt, and then you have a ground plane, a ground fill for everything else on the outside of that.
Yeah. Oh yeah. I flowed grounder. I could turn off the let's see, how do I do this?
Well, I'm just curious if like your second layer down, if that's ground, or if you put like what layers contain what.
Okay, yeah. So the top layer is where I have everything you see here. The
Okay.
inner layer just carries on with the let's see. It just carries on with the whole via stack going down. So there's the same
Okay.
annular rings on each layer. So as this is fabricated, they're just printing copper patterns on a double-sided piece and then on 2 single-sided pieces, and then they make a sandwich. Then they drill and plate it.
Okay.
Let me turn this thing back on. Let's see, just so we can see what it looks like. So this is what it will look like finished. So this is the 1.8, right?
Okay.
This is
And
this is a secondary 1.8.
okay, so under that's on layer 2.
This is layer 2, yes.
Yeah. Okay.
And see, I can still get escapement for all the IO pins. There are these circuits right here.
Yeah.
And
You know, at some point I decided, and maybe I'm wrong, but I decided for the inner layers, I was just gonna do a ground fill for the whole layer and have that connected to the vias under the chip. 'Cause in order to get as much copper on the board as possible.
yes. Yeah, I mean, I don't think we need, I don't think we can't really do this in 2 layers because of the P2. But if it weren't for the P2, we could probably get by with a 2-layer board. But the P2, it's just too, I don't know how you could do this. And you have to go to 4. That's the next step. And the step beyond that is 6.
I will say, as someone that is very amateurish with all of this stuff. After doing a 4-layer board, I will never do a 2-layer board again.
Yeah, right.
Just so what I wound up doing is I wound up doing a ground plane on layer 2. Layer 3, I had various voltages, like high and low voltages on that.
Like
And
in
then,
big bands.
yeah, and then top layer and bottom layer were
Circuit.
signals.
Yeah,
Yeah,
signals, right.
and from what I understand, is essentially whenever you have like the return path for all of your signaling basically follows underneath the trace. It attempts to follow the same path, and that's the least that has the least impedance. Like if you have a ground pour, it will try to follow that. I don't know if
Right.
that's true or not, but
Well, electrons will take the easiest way, so a big ground plane somewhere in the sandwich, and you just
yeah,
drop vias to ground wherever you want. You have those vias just covered by the copper pour,
yeah.
and then they connect up to ground. So you can just, pick ground or power if you have another layer. In our case, oh, go ahead.
I was just going to say this is really great to see this, because I have laid this out a few times for P2 and then chickened out and not actually went that route. Like, I mean, 3 or 4 times I've got so many boards that I've laid out and said, no, I'm too scared to do it, and
I've had to spend like a solid day and a half, maybe a day so far, but it's going to be another half a day, just getting the P2 figured out, like how to do this so that we meet our objectives.
Hey, Chip, I just want to comment, like on that third layer, inner 2 that you're on now. You can put the green in a 1-layer ring on that layer because you're looking to escape outwards. You know what I mean? So that ring, that secondary ring, could be on that layer.
Oh yeah. If I don't, you know what? I'll probably copy it there, because there's no reason, unless I wanted to say, take this IO and then route it around this for some reason,
Right.
Yeah. But I
Yeah.
could add that. I could go 1, 2, and 3, and then on 4, just do all ground.
Yeah. There's a YouTube video on what people select for the layers and why. But usually the second to top layer is a ground layer. And then further down you have more signals, like you've got, that inner 2 layer as you kind of routing, and that provides like a kind of universal plane for the signals, which are both on the top layer, and also the ones which are below that ground plane. So either way, they're kind of closely coupled to a very full ground plane. And the other thing I'll say is, like, with the heat output, like, it depends a bit on which orientation you're going to mount this product in. Like, is the P2 going to be kind of facing upwards or sideways, or but having the ground layer up near the top is good when you've got a P2 like on a desk configuration where it points up towards the roof.
Oh, because it can convey, it's shorter to get out the top that way.
Yeah, and the different sides sort of can radiate different amounts based on their constraint. But the thing is, the heated air on top can just escape, go upwards. So the top radiating surface is always good. And with the way they make the boards, usually the second layer down is quite close to the top layer, just, whether it's a pre-preg or whether it's like a thin core, like it.
Oh, right. Yeah, those are very, very thin extra boards that I don't even know if they're boards. They're almost like foil layers with a little dielectric.
Yeah.
Right? They're very, very thin. It's the middle board that is substantial, that pretty much looks like a circuit board. But it's those outer layers. Yeah, so if I were to put it on the top, that would help with heat dissipation, but it wouldn't allow us to, like, as effectively put a heat sink. Well, we could put a heat sink.
The second layer down is almost as good, because it's only a thin pre-preg down, like you're not far. And a lot of 4 and 6 layer designs have that ground layer as the second layer down, like the one top layer.
Yeah, that could be done. I mean, because we still will have this big square showing up on the bottom anyway, you know, that you could always put a heat sink right on top of, or right attached to. Yeah, maybe we'll even, well, depending on how much escapement I can get, maybe I'll even extend ground. I'll do a ground pour maybe around all this on one of the layers, on one of the hidden layers, just to get even more heat spreading.
Yeah, on my 4-layer board, I did a ground pour on all the layers, and I kind of liked it because it maximizes the copper. I mean, why pay for copper that you're just going to wash away? And then
all that ferric chloride going down the drain.
And then also, I kind of think that having ground pours on top and bottom kind of makes it act like a Faraday cage to protect the signals from any kind of EMI. I don't know if that's true or not, but that's the way I imagine it.
Mm-hmm. That makes sense. Yeah, I'll probably have ground pours on top on every layer in the end, you know, just to fill in everything and stitch it, make every via count more. Because it's free, it doesn't cost anything. I mean, really,
then you just have to add you know, spurious vias through all the layers to make sure they're all connected.
Yes.
At least around the edge.
Yep. Well, what if you had a deal where it could actually like just automatically disperse vias in open spaces where there was room for them that would connect up all the grounds?
Yeah, I think at some point they're going to start charging extra for that, really, right? But
maybe.
I look forward to seeing how this goes, Chip. Like this, you know, this is kind of this via max kind of thing, with all the vias in the middle. You can also pay them. I mean, it's not hideously expensive to get the vias filled, and you can fill them with epoxy and plate.
Yeah.
You can also get them filled with like some kind of copper powder kind of thing that they do.
And I like that. I hear you're working on PLC now, which is, I think I like that because I think PLC is like a really good application for P2.
Oh, it's going to work beautifully, man. It was like P2 is perfect for that kind of thing.
Mm-hmm.
Check this out. I've laid out some other circuits. We've had here's like the WizNet.
Oh, that is a giant board. Oh my gosh. Okay. This is enormous. Okay.
Well, no, I just have everything spread apart now. See, if I turn on the rat lines, look, it's like a big Ferris wheel. But this is the P2 in the middle, right? And these are all the circuits, these are the 24-volt digital IOs.
This is, what'd you say, is 8-inch by 8-inch?
Yeah. Probably 8x4, because the connectors have to span out. Like, see, a connector is like, it's one of these Molex things that you can push a wire terminal, like a 3-wire removable terminal into, that you screw wires into. You can plug and unplug those from these sockets. So that
looks bigger than 8x8. Or you just haven't laid it out?
No, yeah, I haven't laid it. I'm just getting all the parts together because there's so many pieces. Like here's the motor controller. And the funny thing is I got everything on the top layer. Actually, the whole circuit is on the top layer, except where these vias are. They look funny now because they're undersized because I switched things, but those vias go down and connect up to wherever the control signals need to go. But all the components and all the component routing is on the top layer. I spent like a day on this. I mean, here's the Ethernet jack, right? It's an upward facing jack. So the cable plugs in vertically. And then here's the WizNet chip. Here's the ground plane. Wait a minute, there. That's the ground net for the whole thing. So, and you can see it gets stitched together with a few vias up there. But that's the whole circuit on the top side of the board. Except for, you see, the vias up here.
I'm sorry. I was just, do you mind if I ask a question? I was curious why you didn't use the edge.
Because of cost. It's just expensive. Yeah, if we had used the edge, we could have really simplified this board a bit, but Doug just wanted to put the P2 directly onto this thing. What we really needed is the industrial, like the castellated edge industrial module. That would have been a good fit. You know, here are the switchers. But most everything is routed on the top side. So the bottom all other 3 layers don't really need to do that much. Here's an IO link circuit that does like 300 baud serial at 24 volts.
Yeah, for the WizNet, I kind of punted and got their little module that's like castellated that you just solder to the PCB and you're done instead of, doing the whole circuit like you're doing there. But
Right.
Chip,
Yeah, I mean, Edge would have made it easier, but this is what he wanted.
Chip, I like that you're seeing it from the manufacturer's side now because the edge is too costly to put into a lot of products. So the industrial would be perfect, but so you're having to kind of build it yourself. So
Yeah,
I can relate.
I'm sure. Yeah, well, live and learn. There's, yeah, I mean, trying to get this done like as cheaply as we can. We're not cutting corners, but trying to have like a 6-layer board would have been like $40 that size. A 4-layer board will probably be like maybe 20 or so. I will stop sharing now. That's it. But anyway, remember the scheme. A couple IOs on the inner ring, and anyone can review the video and you can kind of come up with the same thing. It's a pretty simple idea. And see, that's a buried via there because it's ground, not buried, excuse me, covered.
Yeah, I like the way you've tucked things away, like that ground via that's sort of hiding in the shadows of the other vias and things. That's great.
Yeah, well, I had to put it there because if I put it, let's say I swapped it with this one and I put the ground via where this guy is, well, then I couldn't run a nice fat trace of copper over those vias.
Yep.
And it would have furthered the distance from, this via to this pad on the bottom side. Because those connect via the bottom.
oh, there's one thing this is the top layer, right?
Yes,
And that's a crystal.
this is a crystal here. Yeah.
Yeah. I personally, I kind of I don't put anything. I remove all layers, all the ground around the crystal, so it's just the crystal connected to the. I don't know if it makes a difference, but that's what I do. I don't have.
Oh yeah.
I don't have.
I know what you're saying. Okay, let me unpour this ground net here, right? I'll say because it'll work unpoured too. Yeah, this is sane for rework. When you have a ground, like a fully enveloped ground over parts like these 0402 cap legs, it is a pain. It's very difficult to rework because you have to heat the entire ground plane up in order to get the solder to molten, to go wet. And that would not be good for, something like a crystal, or even these caps get really difficult to deal with.
Yeah, I don't really have a problem with that. I don't know. Maybe I'm not.
Well, so but you said you don't want to have ground around your crystal?
Yeah, I read somewhere you're not supposed to, so I don't. But I don't know for sure it makes a difference. But
Well, it would just add a little capacitance is all it would do.
but there might be like signals on the ground. The ground may not be entirely ground.
Yeah, so that could result in a phase jitter. But the crystal would still work. You just might get a little bit of jitter.
Yeah,
right?
I don't take any chances with the crystal. I just have it. I don't have anything around it. Yeah.
Oh, I'll put a keep out around it.
Yeah, that's what I would do. I'd recommend.
Okay. Yeah,
How
and then I'll
much do you
put
think
one via.
the ground fill on the top would affect it considering like we're on top of the ground plane underneath?
Wait, say that again, James?
So like we're talking about whether or not to fill around the crystal on the
Right.
top layer, but the layer underneath is ground plane, right?
It could be, well, wherever the ground plane is. Right now I have it kind of planned for the bottom of the board, which is just going to be this. But we
Oh.
could put a via anywhere to attach to ground. Did
So
that answer? Oh, go ahead. Go, Ray.
I was just saying the other thing I do nowadays is I also add, because in case something better than a crystal is needed, I add the
Oh, like for an oscillator?
I add pads for oscillator. I've never had to actually use it, and I don't think it makes a difference, but I always put that in there just in case. I don't know.
Yeah, so there's like a design problem with the P2 that these 4 IO pins right here, this one, this one, this one, this one, use this VIO, which the crystal oscillator also uses. So you don't want any like super high switching going on these pins, because it can cause phase noise on the crystal, which gets multiplied by the PLL and goes crazy. So I'm using, these pins are ADCs, which means this pin, that these aren't going to see any abrupt changes, right? And this pin is going to have a steady current flow through it. So it's not going to bother the oscillator.
Yeah, but if you did, I'm just saying in general, if you don't know what the actual purpose is and there was a problem, if you have the oscillator pads there, you can just switch from crystal to oscillator and overcome any kind of issues you might have.
Yeah, yeah. I guess I'm just not anticipating having issues.
I guess the other thing I do is, I think it's probably Evan H recommended, was having an extra capacitor on that particular VIO.
For this one here, because, well, it's got like it's got this one right here. I mean, it's, and see, ground is right there. Then on the bottom, it chases right to there. So,
Yeah, and the other
and
thing, like you said,
these are 4.7 XR5s or
yeah, but
X5R.
I think
Is that how it
it
goes?
depends on some things, but I think the 0402s aren't really as good as bigger ones. But and then the other thing is what you said about rework. Those 042s rework really easily. I don't know. They just like want to come off. So you don't really have to work on those very much.
Well, that's good to know.
Yeah.
The
Oh, so
P2, the P2 is like a nightmare to rework though, because it takes like I just did
that
one.
ground pad.
Yeah, that's not good.
Yeah, see,
yeah, so I think like one of the other ingredients, like in the crystal oscillator instability, is like it seemed like the eval board, like there was a lot of coupling between the two crystal pins on the board. So like most other boards or so like don't have that feature. So in fact, like on mine, like I ran the 1.8 volt power in that corner there underneath the crystal, where I
Yeah.
have a bigger crystal, and that board didn't seem to have the same oscillator problems.
Yeah, there's an
So
argument.
like this design here, like with the ground plane between the two pins or so, I think that would be good.
Yeah, it would isolate them a little bit.
Yeah.
Yeah, I think there's a good argument for like putting the 1.8 volt plane as the crystal ground, apart from the fact that it's digital and it's got hash on it, so, but it's closer to your switching threshold, like on your pin rather than ground. So,
oh yeah. Well, you mean there might be some like asymmetry as capacitance goes?
yeah. Yeah, I'm curious. So, James, you're saying you use 1.8 volt effectively as the pour around the crystal. Is that right?
No, not like it's like a bigger crystal or so, but then like I have a 1.8 trace going underneath it or so it cuts between the two pads.
Oh, is that your sole 1.8 volt supply?
Maybe.
Yeah, if you don't need, are you running fast or kind of under 200 megahertz?
Well, for the actual applications for the board, I run this board at 80 megahertz.
Okay,
But
so
then,
not a
I
lot
need
of
to
current.
do like a whole bunch of testing with that, or so to try to figure out, or so like, cause I was trying to, looking at building a little, it's like a Pi Pico compatible module. And was wondering like whether the crystal would be stable enough or if it really needs an oscillator. But after the testing, I decided that, I'm gonna go with the crystal.
As long as you don't like swing, like what will mess up the crystal operation, say these 4 IOs right here. Say you make them go all high and all low over and over at the same time together. That'll create enough internal power spike on that internal net, over the bond wires that make up the local power and ground for that pad, that it will cause phase error on the crystal interpretation, reading the crystal input.
Yeah,
So,
so avoid high-speed video. Don't put your DVI, your HDMI or DVI there. That was what was
right.
That's how Roger found those issues.
But you know what? If you're using the DAC bit output, it wouldn't matter because your current's almost constant. It's just giant changes in
But the
current.
DAC bit output is not being used, at least not by mine anyways.
Yeah, for my case, the ADCs are like very safe. They don't.
Yeah, the
There's no.
ADCs, that never was a problem.
They don't draw much, and there's no change in current really. They're just very steady current users.
This looks good as a kind of a reference design example chip, like just for how to break out thermally as well.
Yeah, that was because my first instinct is to lay all these vias right along, and that just isolates, thermally isolates. That's not what you want.
So I guess the next decision is what to do about the VIO power, because there's like, if you're only doing digital, you don't have to worry too much about it, and you can just have a 3.3 volt regulator.
Right.
But if you're doing analog, I want to, for some things, I wind up copying the parallax type approach there and having
Separate regulators.
The main regulator goes to 3.65, which is like at the LDO limit, and then put little LDOs around the P2, just to maximize efficiency, and because LDOs waste power if they were driven by 5 volts, so I drive them at the lowest possible voltage, and then just have one for each of the 4 pins. Yeah, so I think that's if you don't know which pins are going to be analog and which are going to be digital, that's like the generic solution to make sure your analog is good.
Yes. See these ADCs are on their own power net, and these DACs are on their own power net. And this is what Michael had picked. This was like an even better regulator than what we're using on the edge. But look at the size of this thing. I mean, like, this is an 0402, this is an 0603, and this is the regulator. It's a 5 to 3.3 volt low dropout regulator. Let me see if I can turn on, like, I don't think that has a component outline. Yeah. We don't have a component outline for that thing. But anyway, it's no bigger than that. It's just a little square. But I'm kind of like afraid to use that thing because it's so darn small. It's like the size of an 0402 pad, and it's got four circuits.
Yeah, that's in like the stamp has that, and that gets into like things like that. And it gets into like professional mode where the stencil doesn't always work right because the opening, you have to use special solder paste, and then I decided not to do that, but yeah.
Yeah, I was looking for other like SOT23 parts instead, just because they're going to be more manageable. But this would be good on like an industrial module, where we really control the manufacturing tightly.
Yeah, if somebody else is making it, it's fine, yeah.
Yeah, exactly. Yeah. Yeah, I don't want to leave Doug with something that's too difficult. But anyway, but this thing has 100 dB power supply rejection ratio. It's super good. Other parts are like 60 dB. So
Yeah, if you're gonna do that, I mean, why stop at 402 for the caps? You go 0201.
our pick and place, I don't think it can handle 0201. It can do 0402s all day, but I think 0201 might be too small.
Yeah, I guess it's at some point it doesn't make sense to have a giant chip and then little tiny things around it, but
Right. Yes. There.
well, this would be halfway to the industrial module. You just need to make a cutout around it and you're done, right?
Oh yeah. And I also I want to take that little $2 chip that does component to HDMI. So we can take 5 analog pins on the P2 and get stereo 1080p. I mean stereo sound in 1080p, because it's 3 for the video and then left and right for the audio. Those are just DAC pins. And then we run it into this $2 chip. I can't remember the name of this chip, but it's standard. That's what they use in a lot of these.
Oh, is this with HDMI with audio?
Yeah. Yeah, it'll encode audio as well. It just takes care of the whole thing. It's a tiny little chip. It's like a little QFP. It's got like maybe 12 passives around it, like capacitors and resistors. And you give it the analog component video and stereo audio, and it packs it into an HDMI stream. And that way we could, over just 5 pins, get 1080p with sound out.
Yeah, I've been looking at that. The Chinese make a chip like that, but I haven't found any way to buy it.
Oh, Mauser had it. We were looking at it. I can't remember the part number.
Really? Okay.
Yeah, but it's like $2. It's not expensive.
Well, I'd like to know about that chip then, because I've been looking for that, and I know all the VGA to HDMI converters have this chip in them, and it's a Chinese chip, but I can't find any way to buy it. But
Right. This is a component to HDMI. Now I gotta put the word chip in there, otherwise it shows me too many things that aren't.
So the other thing you mentioned PLC, and I kind of think like would be nice is the Arduino people did this. They like use the open source open PLC code and kind of tailored it to Arduino and produced a product that's an Arduino PLC. And I'm kind of thinking like it'd be nice if the Propeller could have the same thing where you make a special, or maybe even just use the regular open PLC. I don't know, but perhaps make a special version of the open PLC just for P2. And, or at least, show people how to use OpenPLC to create code that works on the P2.
Oh yeah.
When you say PLC, I guess you're just talking about running like spin 2 and in the thing that does what a PLC does, right?
Right. Yeah, it would just be spin 2. But the PLC, the way the PLCs often talk to like peripherals is they have this UDP packet exchange going on where it's just like they receive register data and they send register data over and over. So you do things like motion control or sensor reading by looking at bits, or if you want to do something like make a motor move, you'd set some parameters in some bit fields, and then you would toggle a bit that says go, and then you would wait for an acknowledge bit back in the incoming registers, data. And so it's like that. It's like really simple handshakes that occur over register sets. So it's kind of a neat idea. And I don't know how else you do it to really make it flexible, but what we could do is you could just deal with that memory interface, the register memory interface, via a cog and then deal with it directly. So you're not really having to worry about controlling the motors. You're doing what this thing will do anyway. You're just giving it the commands instead of having it, hook up over UDP and talk to a PLC.
Yeah, the thing about PLC, okay, so you typically they have like a main loop with a fixed timing with like, I don't know, pick a number like 100 milliseconds or something like that. And everything has to get done within that time. And they try to squeeze stuff in. And so you have to like, in like regular PLCs, you have to like set priorities for stuff because if it doesn't get done in that, if it's not going to get done in that loop time, they're just going to skip it.
Yes.
And that's the real advantage of the P2 is you just push all this other stuff to other cogs, and anything that's time, that takes that you don't have absolute control of the time over, you put to the cog. So the main cog is absolute time, perfect timing. And I think that's why the P2 is a good solution for PLC, I think. Yeah.
Yeah, I'll have one cog. There's a bunch of shift registers that we're using 74 HC 594s, which are like 595s, but they have a master clear. So you can on reset clear them all. Then you shift data into them and hit a latch to update them all in parallel. And then we use 165s going the other way, 74 HCS, they have Schmidt inputs, 165s, and that's how we sense data coming in. So we have kind of like what is a SPI interface, just made out of logic chips, one chip for every 8 inputs or 8 outputs. And I'll have one cog just sit there and reel that data in and out and update the register map, and then also control all these RGB LEDs that are on each connector port where you want to have some status indication of what's happening.
Yeah, and in terms of PLC in general, I kind of think, it's nice to implement some communications protocols. You mentioned UDP. I think Modbus is like a really well-established one that's really easy. So I've been working on that. And there's also Profinet, which
Oh, yes.
some people had this misconception that that's proprietary, but it's not. So that's another I think equally valid approach. And then there's CAN bus, which I don't really know about, but I think it's probably the same thing. But yeah, so it'd be nice to have all these protocols available someday. But
Yeah. Well, we're putting IO link on this, which is like 230.4 kbaud 24-bit serial, which it's not a nightmare like USB because it's just a point to point. There's no like extra network, so you know who you're talking to. You don't have to go through all kinds of discovery and negotiations and all that.
yeah, well, the nice thing about Ethernet based things is you can put it over fiber, and plus it's self what I want to say, error checking. So you don't have to worry about any errors in the data.
Yeah, it takes care of all that for you.
And you can run you can run it over miles of fiber and things like that. So yeah.
I wish I knew if I saw the part number, it would ring a bell, but Michael and I looked it up and we had a lock on it, and Mauser was selling them, and you can get them from a few other places.
Yeah, that sounds pretty awesome. I haven't found one. I saw a kit with one that had something like that in it, and I tried to find out information about it, but it's like, yeah, no, there's nothing going on.
Oh, is it a 9138A? That might be it. That sounds familiar.
The other thing is, there are some chips like that, but you have to like sign NDAs and like legal agreements to find any information about how it works. I don't know if this one's like that.
No, because we downloaded the data sheet and we were looking at the reference schematic, and I think it might have been kind of Chinesey though.
So I think anything that has encrypted video is going to be hard for the average person to get hold of.
Oh yeah.
So if this is something where, the video isn't encrypted, then I think that's the kind of thing you can get hold of if you can get hold of it. Yeah.
I think this is where, like Werfel was referring to the HDMI transmitter, thing, which, yeah, like a lot of those chips just talk about HD transmitter rather than being HDMI compliant.
I mean, technically, a lot of what's being done is just DVI, which doesn't have the audio.
Mm-hmm.
And I mean, the P2 doesn't have the audio unless you wrench it in there with bit banging,
Right.
which, I've had some success in that. A lot of it, in fact. But it just doesn't do the high resolution stuff. It just
Right.
doesn't.
Yeah, that's our problem, is that we're stuck in low res.
Yeah, so component to our VGA to HDMI is really nice. I think, a perfectly acceptable solution for me is just to use, the $9 VGA to HDMI converter cable off
Right.
Amazon. But it'd be nice to,
Probably easier to just do that because, well, it's probably depends on how much it costs to integrate that chip into the board versus just providing the regular analog connector and yeah, just plug whatever in.
yeah. And then
Because
yeah,
sometimes you can actually just plug it directly into an analog input.
yeah, I'd like to actually be able to buy the Chinese chip that's in those converters, but
Yeah.
you
Yeah.
can't find it anywhere. And then there's one other kind of thing I was looking at. It's kind of interesting. There's a USB 3. I think it's FTDI that makes it. There's a USB 3 chip. We just send it parallel data as fast as you can, and it shows
Oh,
up. It shows
yeah.
up as a camera on your computer, and so you can get high resolution. I don't know how practical that is, but you can get like high resolution video out of the P2, and it shows up as a like a camera on your computer. So that's kind of interesting.
Yeah, that
Yeah.
is.
I think that was like a really expensive chip though. I've looked at that one as well.
Yeah, FT902 or something.
I mean, I've got the little capture vision RGB thing, and that ostensibly shows up as a camera adjacent device. And that just takes the HDMI input, DVI input. It doesn't actually do anything with the audio.
But yeah, Chip, if you can find that chip, I'd be interested to see that.
I'm looking for it. Let me search. A Google search is not turning it up. Let me check.
Google search is turning up nothing these days. It's terrible.
Yes.
You can't find anything anymore.
Yeah, it's kind of there was an Efinix FPGA board that had a VGA with sound converter chip, and it looked beautiful. And I asked them for information about it, and I found the company that makes it, but they don't sell to people; they sell to like companies, so you can't just buy it.
Yeah.
What currently messes me up, because I've just had a different thought, is I can't seem to find one of a box that takes an HDMI signal and actually extracts more than 2 channels of audio.
Mm.
I get a lot of them that have an SPDIF out, which presumably gets a copy of any bitstream audio you send, which I guess is enough for most purposes. But if I were to try my hand at multi-channel audio, because I don't actually have anything that takes multi-channel audio in digital, because they messed it up at some point and never specified multi-channel over SPDIF.
Mm.
Which is very strange, right? Like you can do something that has the equivalent bandwidth, which is like, right, you can do like 48 kilohertz, 24-bit normally, but you can also do 96, which is kind of off spec, but everyone does it because it's just the same thing as 48, but twice as fast. But then if you consider that 96 by 24 is the same amount of bits as 48 by 16, but with multi-channel. Okay, I'm not explaining it right. All right, so 48 times 96 times 2 times 24 is the same as 48 times 6 times 16. That's what I want to say. So technically the bandwidth was there, but they never specified it for SPDIF to do that. But HDMI can do it, because HDMI can do everything, except when it can't.
Right.
That can do up to 8 channels at any rate. But then you can run into a problem. Actually, 8, yeah, it goes up to 8. Because, yeah, it goes up to 8. But the problem is that none of the stuff I have is actually all new enough to support that. And bizarrely enough, if you buy a new, like, well, what they're doing now, 11 channels or whatever, 11 channel amplifier with like your height speakers from that you put on your ceiling and stuff, they don't take more than 8 channels over the HDMI either. You can't use the height channels if you're just doing PCM over HDMI. And you also can't do it over like anything else. The only thing you can do is bitstream in something that has height data. And of course, those are all proprietary codecs.
Yes.
That's a really bizarre thing I just came across while doing like research. You can buy an amplifier that doesn't have the inputs to actually amplify the amount of channels that it has. Because of course, either they don't have the discrete analog inputs because they're kind of niche, or they have them, but they only have like 5 or 8 or 7 of them. Of the discrete analog inputs. They never have the actual full range of analog inputs. Of course, you can just buy a bunch of regular amplifiers, but then you cannot listen to the bitstream audio from like your movies or whatever. That has the height data. Because where are you gonna decode it?
Yeah. I found the chip. I put it in the chat. It's an MS9288A. DigiKey and Mauser don't have it. Okay, but let me just search for it.
Yeah, that's the problem I found is you can find these chips, but you can't find, there's nowhere you buy them from. But
Okay, so well, we had it figured out. We had some distributor that was giving us a price. It was it's an MS9288A, and it'll do VGA or YPPPR and audio to HDMI. Oh, here it is. LCSC Electronics. Oh, it's 98. It's 96 cents.
yeah, I think that's
Check.
that rings a bell. I
This is
think
it.
that might be the chip that's in these converters, but I don't
Yeah,
think
yeah.
you can actually buy it anywhere.
No, here, right here. Look, there it is.
That's a cool data sheet.
Yeah, we don't know Chinese, but
Yeah, I see it there, but they want $1.64 per one. Blah blah blah. Where's the data sheet?
where did I put that? My window's gone now.
Oh Lord. Well, I wish it was in French.
Yep.
It's what the well, parts of it are in English. The bottom part of it is kind of.
Doesn't seem like it's saying a lot of, like it has a lot of information, like it's only 13 pages.
They don't say did well, it's really difficult to the Chinese, it's not helping.
It's like, yeah, just put this in your circuit, it'll do the job. Don't
No,
ask
but-
questions.
But you can
That's
look
the
at the
kind of-
reference schematic. It's pretty self-explanatory, I think.
Yeah, that's what I'm thinking about. It's like they don't explain how it works, you just put it in and it probably maybe works.
Yeah.
So we've done some work with that chip.
With that particular chip?
Yeah, to P2. Yep.
Oh man, well, what happened?
Let's do it on a separate stream. Get our demo together. But
Did it, I mean, I have converters I bought off of Amazon that have that thing in it and they work great, but
yeah, that's right. Yeah. That all those little converters, they tend to use this same chip, and I'm trying to remember all the detail, but I need to talk to Roger. It's really Roger. It's more Roger's project than mine. So
I see.
Yeah, it might be it's easier and cheaper just to pull the PCB out of one of those converters. I don't know.
So
yeah.
now that I'm making circuit boards, I mean, I could make that board in one day and just make it plug into the little 12-pin connector that we have, you know, for all of our P2 stuff.
Roger
And
basically did that, right?
It's all the stuff you don't know that comes back to bite. It's not copying the circuit board, it's the rest of it. So yeah, it's really I'll see if Roger can chime in or start a thread or something about it.
yeah. Well, you see, they have a reference schematic here, right?
Sort of, yeah.
But who knows what you're supposed to configure in the S. There's an I2C port that's probably
Right. There's an EEPROM on it as well.
oh, so they actually have. I remember seeing that there was like a separate.
Well, they have the
EEPROM.
EEPROM for the, so if you plug VGA in, then because the computer needs to know what resolutions it can send,
Okay, so it's like
and that's why it uses that, right?
Oh, so it uses the EEPROM. It doesn't. So that's a master port.
Yeah, basically, this kind of needs to go two ways. In a sense. Actually, it's kind of strange and unusual because technically you'd have to connect to both ends of it, because the device that if you're an adapter anyways, because or you maybe pass it through. I'm not entirely sure, but the point is that you've got these DDC signals that are used primarily to query the EDIT, which is the extended display information, whatever. And that's what the computer uses to figure out, okay, what resolutions can I put on the screen? What resolution would the screen like to get? Because with an LCD, you really want to have the one that likes the most, so it's sharp. And that's actually, interestingly, that never changed. That got invented way in the past. And the data format's been extended a bunch of times, but the fundamental idea of having this I2C thing that goes from the computer to the display never changed, and that's still being used, I think it's still in DisplayPort as well, but HDMI definitely has it.
Yeah, but if Lachlan and Roglo couldn't figure that out, that's a red flag for me. I'm not gonna.
Right.
You're going down a rabbit hole.
It's a rabbit hole. That's correct. It's a rabbit hole, but it's yielding fruit. It's just it's really Roger's stuff to talk about, and I don't
Also,
really.
why does this have an encrypt engine?
No, because it's not. It's like you called it, Ada. It's the HD transmitter in inverted commas, not you know, like not the.
Yeah, but it says something about encrypt engine in the block diagram.
Okay.
Which is kind of interesting because what they're gonna do with that?
Yeah, that's the problem.
Do that?
Yeah, anything with encryption is like, it looks to me like you forget it. You're not gonna.
Well, I think it's more so the ones that do the decryption that are the important ones to sort of keep out of people's hands, which is kind of bullshit for the old style HDMI anyways, because that's been circumvented like all the way to the moon and back. Largely because people. So there's a very interesting thing. When they made the PlayStation 3 many years ago, they put an HDMI output on it. And somehow in the circuit design, they made the very clever design choice that the encryption is just hardwired enabled. You cannot turn it off, no matter what. Then YouTube happened like a year later or something. and people wanted to upload the like funny videos, right? So suddenly it became very profitable to sell people something that could record HDCP protected video, and very desired. So some very interesting devices that came up that just kind of did that, but not like, oh, this is the piracy dongle that you plug in. But it's like, here's an HDMI splitter that we've deliberately poorly designed, such that when you plug the source in, it decrypts the source, but then it doesn't re-encrypt it when it sends it back out, which requires a very interesting kind of circuit design, because you need to decode everything and then apply the XOR cipher, and then re-encode it to make that happen, which is a very interesting thing to do in a split box. But perhaps a cheap thing to do in a split box, if you can get like a parallel decoder that just spits out your parallel data, and then get 2 parallel encoders and then sort of gang those together. Plausible deniability, basically. Yeah, we totally didn't make like a piracy device here. We just screwed up. Oopsie doopsie. The newer ones, this newer 2.0 stuff is a bit harder to have that problem with, to solve that problem with, I mean. But that shouldn't be a thing that you worry about with like the 1.x stuff. But also they sell like weird dongles that downgrade the encryption. So I don't know what the fuck is going on with that stuff. It's kind of pointless anyways, because no one does that.
Right.
Like the guys wanting to copy Blu-rays, they just copy the Blu-ray instead of trying to record it from the output. It's kind of pointless. But someone wearing a suit and sitting in a big chair thought, yeah, that's a real necessary feature to have. We totally need that. Because otherwise we'll lose 5 cents.
Right. So I've pointed Chat GPT at it and asked it, and now it's translating like sections of the data sheet and explaining them in English to me.
Oh, that's a good idea. I like that.
I found that this AI, it can't do your work, but it can answer, or try to answer any question. So it's very useful for discovering things, but not for like doing actual work, but it's like because it just parrots back all kinds of knowledge, that humans had put together in the past. And so it's useful for that. So I use it pretty habitually just to try to get to the bottom of things I don't understand. Like that's how I learned about what's the difference in practice between 4 and 6 layer boards, and the cost differences and the likely geometries and all this. It just can tell you stuff like that very easily.
If
Whether it's correct or not is a number question.
if that board has a EEPROM on it, you're probably going to wind up having to
Yeah, we have to
copy
program
the
it.
EEPROM. Yeah.
Yeah, so let's see. That thing is acting like a transmitter. Never mind where it's getting its picture and sound from. It's transmitting. So does that have to like negotiate with the monitor? Like, can you do what I want to
No.
do? Or
The monitor just does whatever you want to do.
yeah. It's all
Or it
this.
doesn't and just has no signal. In the case of like a converter like this, there isn't really a choice that the converter can make.
Right.
Because
It
it's
can.
getting
It
the
did.
signal, right? Like what's it gonna do with that?
Right.
It can only send it in.
Right.
Maybe it's because they want it to work if you've got like a DVI only thing connected. Because the only way to find that out is to ask it on the DVC. Is this an HDMI device? No, yes, no. Which really isn't a negotiation. It's more like just reading out that I2C EEPROM.
Yeah, but if you don't
Whoa.
need audio, then the TFP 410 is like really easy. But yeah.
Yeah, I was trying to remember. That's the one you did, Ray, wasn't it? The 410, the TFP.
You mean the one that the encoder one or the decoder one? They have similar numbers.
Yeah, if you're making yeah, there's the 401 and the 410, I think. That's how it goes, yeah. But
Because the decoder one can technically do audio, as we've discovered. It just won't give it to you in like a reasonable format. It will just basically, it doesn't blank out the video pins when it's receiving the blanking signal. And on those video pins will appear codes that correspond to the audio data. So if you sample it just right and sort of do the decoding in software somewhere, you can grab the audio out of it.
yeah, I think I looked into all this many times, and I think I just decided ultimately it's just buy the thing from the $10 thing from Amazon and forget it.
Yeah, well, so I remember, so I think, could it be that the EEPROM, the I2C EEPROM in those boxes is configured to say, I am a 1080p primarily, but I can do 480p, I can do 720p, I can do other.
Highly likely, yeah. It has to have something there, otherwise it will either not detect, or like the source will say, I don't know, I'm just doing 800 by 600 or whatever the hell it's doing. Of course, it's only relevant to VGA if you're doing component. Well, where does the I2C go? Nowhere. Component is just.
Or maybe that chip has an FPGA component that gets loaded by the EEPROM.
Yes. Yeah. I mean, is it talking to the EEPROM on its own steam, or is something there? It must be. I mean, the EEPROM probably is programmed once, and I don't know if there's another microcontroller on that thing that has to do anything. Here we go. So I said it's telling me all about the travails of analog, and I said I have a handle on that. Just what about the I2C interface? It said, great, here's what I found about the I2C interface of the chip and how you'll want to hook it up in your system. Okay, note, the data sheet and register map is not publicly fully free. Multiple sources say you must sign an NDA to get the full register map. So what I'll give you is what is publicly known, plus how to plan it for your design, or how to plan for it in your design. So this chip supports an I2C slave interface for configuration. It also supports a master interface for DDC control. What's DDC?
Yeah, configuration, that sounds like FPGA to me.
Yeah.
No, it's probably just like registers that you set with a microcontroller. The DDC thing is just the DDC thing.
Okay, here's what it is. In practical terms, that means the chip expects an external microcontroller, your P2 for instance, to talk to it over I2C to configure video format, set gains, detect input mode, RGB versus YPBR, for example, select the correct internal mode, possibly handle EDIP, HPD lines, etc. So, okay, so it's used for control and configuration. Not for streaming the video data, of course, it's just control.
DDC is direct digital control.
Okay. Yeah, let's see. Okay. Oh, okay, here it goes. It says, at startup, your MCU will need to write a series of registers via I2C. Also, detect which is active, RGB versus YPBR. Set the ADC gain and offset. Set output format, HDMI versus DVI, color depth, like 24-bit, the resolution, sync settings if the chip allows, and then set up the DDC EDID pass-through or whatever, or whether it fetches display EDID from the display sync, possibly set audio input enable disable.
Well,
Okay, so
that sounds like it's saying
actually,
you can either use
it says here that it has a built-in MCU, and the MCU cell pin is apparently selects whether you want to use the built-in one or you want to use the external configuration. So it has some sort of built-in thing.
So it
Okay,
has,
yeah, so the
Which is
EEPROM
why
is
nothing
probably,
like that shows up in the example circuit.
yeah, the
And I
EEPROM
found
is
that out by
probably,
just clicking on it and pasting it into a translation box.
yeah, so the EEPROM
Maybe
is
that's why it's more
probably,
accurate.
programming the MCU, like, sort of like the P1.
oh boy. Oh boy.
Yeah, so I'm saying, I think you need to clone that EEPROM if you can.
Right.
Yeah, that's the way to write. In China, you just copy the thing and then it works.
Yeah. That's the SOP. Yeah, so after initial setup, the MCU might monitor status via registers, whether input signal has changed, sync lost, resolution change, audio mute, etc. Okay, so the good news is we could take 5 pins, right? 3 for YPBPR, 1 for left, 1 for right audio, and then 2 pins, I squared C. That's a total of 7 pins. And then things we don't know, but that would be the totality of the electrical interface.
No, to me, it sounds like you have two options. You can either use your own MCU to talk to that chip, or you can have the EEPROM programmed and have it talk to its internal MCU. So I don't think you need the I2C at all. If you
It says here something. I'm just dropping the thing into a translation box, and it gives me very interesting things. It says supports encryption via external EEPROM. It never says that the external EEPROM is required. And it would make sense because it's not on the default, it's not on the reference schematic that they give you. There's no, it only shows you the DDC. It doesn't have anything else.
Well, that would be good if that's true.
So it should just work with just the reference schematic. Read what's actually in the datasheet. It will elucidate you.
Yeah, the other weird thing is that I think this thing is like in all these converters, but some converters work better than others. So I'm not sure how that's possible.
I mean, I'm always questioning how these work well at all, because usually when I plug something into an LCD monitor into a VGA source, it always has like phase and clock issues. And the automatic calibration usually doesn't work that well. You have to invoke it on like a checkerboard screen or something like that to make that work at all. And even then, sometimes you might have to tweak it manually. So I don't know how these converter chips that don't even have an interface for you to say, okay, well, maybe you can do it over the I2C interface, but they don't usually, when they're in a product, don't usually have a button that you can press to say, I want to adjust now, or I want to change something. I want to change the sampling frequency, because that's a fun thing. How do you distinguish between like a 640 by 480 and an 800 by 480? They're the same, right? But the chip will decide some sampling rate.
For our purposes, though, what we would do with it, it would be simplified, because we know exactly we're going to be doing one of 3 things. We're going to be doing 1080p, 720p, or 480p, or some VGA mode. We'd have like a very limited subset of what we'd want to do.
Yeah.
If you're sticking to something that's vaguely specified, then it's probably gonna set the sampling rate correctly, at least.
Yeah.
Yeah, the other option is to try to get a FPGA to do it for you. And I think that can work too, but that's also rabbit hole.
Well, we need like very fast 10-bit A to D converters, because we can pump.
Well, I mean, you could also just do a digital interface to it.
Take tons of pins.
I wonder how annoying it would be to like share the data pins of like a PS RAM with something else.
Well, if you don't care about cost and things like that and size, there's also a chip that can take VGA input and put out 24-bit digital video.
Yeah, no, I'm thinking about what if you had an FPGA and that just pulled video from the same from the buffer directly.
Yeah, so I've struggled with this in the past. I had a board, or I had the chip that can take the VGA signal, make 24-bit digital video, send that into a TFP 410, send HDMI at 1080p. But the problem is there's no audio. And the
Yeah.
audio stuff is you have to like sign an NDA and they don't want to talk to you unless you
Well, I've
want to
done
buy
the
it.
audio implementation in software. So everything's possible. They're just nasty about it. Problem is getting your bit banked audio in with something that's generated somewhere else. And I don't think you can properly do that with any sort of generic. I've talked about how the parallel decoder can give you the audio data, but I don't think the encoders can generate the sort of framing around that it needs.
Yeah, I think the main issue here is that, and DVI that includes audio, HDMI, that is usually assumed to be encrypted. And when you get to encrypted, then you're talking NDAs, legal gets to get involved, and they want like minimum orders of like 10,000 or stuff like that.
Yeah.
Yeah, that's kind of actually a good question. Have they figured out how to do the HDMI audio anywhere else? I know some people have figured it out on FPGAs. But like I wonder how to what extent the work I did is actually kind of unique. Because I know they all have issues where they say, oh, it doesn't work on some TVs. I may have cracked the code eventually. Eventually I'll find more incompatible TVs, I'm sure.
Yeah, Chippy, do you actually absolutely need high definition, or is just regular VGA good enough?
Well, it just comes to like, what can you plug it into? Everything today is just HDMI.
Well, Edit here has HDMI working with sound at 480p. So if that works, that you don't need anything.
And that's 480p with a lot of blanking at high refresh rates, at high P2 clock rates, I mean.
Right. Well, that's good, but it would be nice to be able to get, high quality video out that looks good on a TV.
I mean, it does look good.
Yeah.
480, yeah, on a small monitor, but you know what I mean? It would be great to be able to show lots of text, for example.
That's more like it.
Then you're also going to need external memory, right? So you're planning on having some PS RAM on your board?
Right.
I mean, you can show text with just the regular output, with just synthesizing the text buffer in real time. But yeah, I'd have to figure out what's the max resolution I can get out of the HDMI driver reasonably. Because right now I can do like widescreen 480p, which shouldn't really help much with the texting, but the same energy could probably be pumped into making something that's slightly higher.
Yeah, I mean, if this is for a PLC, so a lot of times just VGA resolution is good enough. I mean,
no, it's not just that. It's just general interest, I'd like to have something that just looks good that anybody could take, plug into their TV, get a nice display, and maybe program the chip.
Yeah. Well, I think either buying the $10 cable or reverse engineering is probably the best solution there.
Well, maybe we'll contact this Macro Silicon and ask and say, hey, how can we get on board?
Well, they may talk to you. They won't talk to me, but yeah. So
yeah.
We
Who knows?
We need Roger to chime in with where he's up to. Would be good. Yeah. So he has something working already.
Yeah, the part's cheap. It looks like we could do it over 7 pins.
Yeah, like I said, there's an eFinix board that has, I think it was a Taiwan part that looked a lot more straightforward. But I couldn't get any information on that one either, and I couldn't find anywhere to buy it. So yeah.
Yeah, it just the whole idea is just a simple consumer level plug and play stuff.
Yeah, I don't know why this one is so hard. It's like, yeah, I think it's all has to do with the ability to do encryption. And any of that stuff is like blacklisted.
Right.
Oh,
Well, they
so
may
the
not.
other, like, you know, that I had talked about generating an RF digital TV signal. Well, I made some more progress on that. So, you know, the
Oh, you mean
American,
it? Oh, yeah, digital
yeah,
TV signal.
ATSC, you know, I got the complete signal chain running. So it'll take an arbitrary MPEG transport stream and send it out one pin to the antenna input of the TV. So now I just need like an MPEG-2 encoder in order to actually display something other than a pre-recorded video.
Right, right. And that's going to be, gosh, what a long way to get to showing someone a picture. But
Well, I
that's
mean,
kind
like,
of, but you're,
yeah, it's a trade-off, or so is like that. So like you know, I'm using 2 cogs now, but then it's like the MPEG encoder will probably need at least another cog.
yeah.
So then,
Yeah,
you know, we're talking 3 cogs or so. Well, how much does 3 cogs cost compared to a $1 chip?
you know, if we just had like a faster process, we could just do the same thing we're doing now, but faster, and we could signal all this stuff just fine. No problem.
I wonder if it's possible to have like a PLL or something that just drives the shift register. I think some of these FPGAs have that.
Well, they also have
Hmm.
like DDR latches and stuff too, right?
Yeah. Since I've been working on this PLC thing and I have like these IO expanders, you know, these 74HC 594s and 165s and all this. And so
I
this
mean, I
stuff's
remember the P1 did have a PLL that powered the shift register, right?
a PLL that, yes, it did.
Why don't we have that anymore?
Because I did that as a full custom design, the P1, so we could do whatever we want. But when you're doing with like standard cells and a logic synthesis flow, that stuff is like it's different. And we didn't have an extra PLL too. Mm.
I mean,
You
but
know,
like, you know, unless the logic could run faster, it's not really going to help us. Or so we're like, well, I thought for 180 nanometers and about 350 is about the limit for that.
yeah, we're at our like our technology limit. But gosh, if we could just get like any of these new processes, isn't it crazy? Transistors are cheaper than they've ever been. But to have anything made is now more expensive than it's ever been.
Yeah, it's kind of crazy. Like everything's getting priced out, and all the people that are making stuff, they're either keeping it to themselves or they're like doing weird stuff with it.
Yes.
And that's where you could get amazing stuff like the aforementioned thing where you can get a multi-channel amplifier where you cannot actually amplify more than 8 channels from your PCM source, because I guess no one makes a chip that does that, or like they deliberately don't enable it or something.
Mm-hmm.
And like no one can make a similar one because it's also insular with the parts. Because if there was big competition, people would just go, okay, we're doing it now. We're doing everything, but they don't. I guess they're all being bought out by Dolby or someone. I did, by the way, find a box that claims to do the actually do 8-channel analog output from an HDMI thing, but I cannot buy one. They say they're out of stock. And also probably it looks like something that would probably cost a lot of money if it was in stock.
Right. Ada, I have not forgotten about getting you that Cordic thing. I started looking into like how to set up an NDA, and I got so far and it was just like, I just gave up. But then
Yeah,
I
you can
figured,
just have it on. I mean, you could just have it on. Yeah, I'm just not gonna tell anyone about the thing.
right. I mean,
Maybe Ken doesn't like that idea.
the only
Nope.
reason, I mean, I would just share it all, but if Parallax were to ever be in a position where someone wanted to buy that, we just want to be able to tell them that, you know, there's a chain of custody that's been followed with the IP. So even though nothing's patented or anything, at least we can say like the design never went out into the world. So what you're buying isn't just free. But you know, that probably won't happen anyway, but that's the idea.
Uh-huh.
I wish there was a way. It just takes so much money to make anything better, and we don't have the, you know, volume to justify it. But it sure would be cool. I mean, imagine if we could. Go ahead.
I mean, even if the current volume stuff's really expensive, right?
The what value?
Yeah, if you're making at the current volume, you know, the chip's costing like $14 or something. And then you have the boards which cost like $70.
Right.
So if you made a nicer chip, then it would probably be so expensive that no one wants to buy it.
Well, it would be way smaller and lower power. It'd be easier to do a circuit board for, and it could run like 4 or 5 gigahertz as opposed to 340 megahertz.
That's plenty fast.
Yeah, I mean, we could just signal all this stuff, you know. All we need is the same thing we got now, just more memory and higher speed.
I mean, even the memory isn't that bad. If you could put more memory in it and configure some of it that it can act as like a cache for an external memory, I think just having maybe even 256K just as the fast memory, and then like the rest as cache for the external memory might actually just, because a lot of the things that happen, they're not that sensitive to actually having that low latency stuff happening. They just want to happen at some point, and they need memory. But if you've got the space, you could probably do the 1 megabyte internal and then just do another dedicated cache part.
Oh, if we get one of those type processes, we could put at least 16 megabytes, maybe 64 megabytes right on the die.
Yeah, just on die DRAM. Yeah. They did that on like the PlayStation 2 GPU. They just put the DRAM cells on the same die as the processing part. And then it fetches like a whole row of DRAM at once. And I don't think they can even process it fast enough to actually make the memory happy or something. But the point is they can very quickly fill in stuff on the memory. But they kind of sacrificed everything else for that. They've got only 4 megabytes of that memory, and it kind of has to do everything. And also the processor that's in the middle can only do like basic triangle rasterization with like texture. It can't do anything complex. But it's very interesting that like half the die is just the DRAM on that thing.
So, Chip, I've got a question with that converter chip. If you had that running, what would you do with it? Like, would you make a board, or would you make an adapter, or what would you do
We'd probably start
Okay.
off making a little board, that would plug into one of those headers. But then I would want to put a P2 down on a board with that circuit, with some PS RAM, and build something that could, be like along the way to being a little computer.
Mhm.
I mean, we've got the little box here, from it's a funny Italian box. Where they've got.
I mean,
Yeah,
it could
video
just be
stuff.
fixed at 1080p. That would be sufficient. 1080p is fine.
Well, this one has the direct HDMI output, obviously, because that's fine for my stuff. Wow, I think the video's gone really dark. Has it?
Yeah. Not much ambient light.
No, there's plenty, but it's like, I think I've messed with the settings at some point and then got stuck on that. Yeah, anyways, the box. It's kind of like a little computer.
Mm-hmm.
The main thing that it's missing is software.
Oh, wait a minute. That's what somebody showed us last meeting, right?
I mean, I've showed this one before. Last
Yes.
meeting, wait.
A month
the meeting
ago?
that I wasn't there for. Good question. I might have missed that one because I was out of the house. And indeed dealing with the HDMI thing.
You went to Stuttgart, I remember.
No, it's more like Frankfurt, but it's also not really Frankfurt. It's kind of like vicinity of Frankfurt.
Hmm.
But I will not specify further because, privacy and such. Anyways, I had this along and it didn't work on the TV.
Ah, that's right. Yeah.
And then I fixed it and I went back up and then it worked on the TV.
Mhm.
And we played and I lost. Amazing. And then we played the money puzzle exchange and I won. So it's all. The balance of the universe has been restored anyways. And of course the HDMI bug has been fixed. That had to do with the preambles that you need to send before. So for HDMI, you have to send a preamble before video and before data, so that the device that's going to receive it knows, okay, we're getting video, we're getting data. Now I had wrongfully and foolishly assumed that the preamble just needs to be at least 8 cycles. But no, it needs to be 8 cycles flat. So I had to change the code to do 8 cycle preambles instead of just making the entire blanking a preamble, and that was really annoying. But with the new code, it now works on every TV that's been plugged into. I'm not aware of any that don't work.
Okay, so that's injecting the audio data into the HDMI stream.
I've got what?
You're talking about putting audio into the output on HDMI, right?
Yeah, that's my code that does that, right? And I fixed it. It now works even better than it did before.
Wow.
And with this preamble issue, that was really nasty. Because usually when you do a flub with the audio, it just doesn't do the audio, right? You still get the picture. But with this preamble stuff, it actually killed the picture too. Like you just get no signal, which is very strange because there is a signal. It just basically didn't react to the thing being plugged in at all, unless I changed to something that did plain DVI, which doesn't have the preambles and therefore doesn't have the problem. But then I fixed the preambles and now it works.
Cool.
And actually, I was about to try to calculate what sort of bandwidth I could probably put into the into this in terms of video, like if you wanted to go high resolution. I had an IRB open somewhere for this, but of course, I have a million IRBs open. There we go. So if we did like plain 720, we know that's too much. That can't be done.
Well, I was doing quarter HD, but that doesn't work with all TVs.
Yeah, some of them are like weirdly picky, but also it might be the way you're signaling it.
It was like 960 by 540.
Did those same TVs work at a lower resolution? At like a standard 640?
Yeah, they'll all do
Oh.
640, but on a big screen, 640 by 480 looks so blocky.
Well, it depends on how it's configured, but yeah, it's not that amazing. I mean, it's pretty fine on this Asus one that I've got. It's all nice, but it's certainly not fine detail. Yeah, we're almost exactly at half the rate that you'd need for 720p.
What about 720i?
I don't think that's a real mode, but
Oh.
1080i is a real mode. And I think it's one of the standard ones that you have to have. And that's essentially the same as 540p, but wide. But I'm not sure if they let you get away with that on a. Actually, I have to check out what the standard timings for that is.
Oh, it's
that's
half. I remember. It's 148.5 megapixels per second for 1080p, and it's half of that. So it's like, let's see, if 148.5, half of that is going to be 72.25. Is that right?
74.25.
Yeah, 74.25. But that would mean 720 megahertz out of the P2.
Yeah, that's still too much. Oh, I've got one that lists the clock outs for the standard modes. That's still 740 megahertz. Yeah, that's
Or 74 megahertz, right?
yeah, 74 pixel clock, but then you have to have 742 TMDS pixels, TMDS
Oh,
bits.
yeah, 10 bits.
Yeah, we're going. Yeah, actually, it would appear that they've cleverly chosen the timing such that 1080i and 720p have the same
Clock rate.
the same rate, right? I wonder if we'd be able to get at least 800 by 600 with reduced blanking.
Yeah, I think we've done that. Although we might have done it at a lower frame rate.
Yeah, it's kind of annoying because there's like a subset of modes that are required. And besides the 640 by 480 one, all of them suck because they're way too high. Now, in my experience, found that at least the timing doesn't matter very much. Like if you send 640 by 480 and it's got like weird blankings on it, I don't think anyone cares about that. But I think there's some TVs that don't like it when the numerical resolution that's active is weird. And that's maybe why they sometimes don't like the 540p.
540p, yeah, that would have been what it was called. What if we could do a 540i? That doesn't exist, right? There's only 1080i.
You can do 525i. Actually, yes, you could. There's the PAL modes. Of course, the PAL modes exist. They're slightly higher resolution and they're standard. But I think some American stuff still doesn't like them because America.
Right.
I don't know how that. I don't even know how that happens because don't the chips all come from China? And China is historically a PAL country.
Today they do, yeah, but Yeah, 525i, that would probably signal at some lower rate.
We have to actually we have a list of required specs somewhere. Where's the sync reported? An HDMI sync that accepts 50 Hz video formats shall support the 640 by 480 60 Hz and 720 by 576p 50 Hz format timings. Awesome, awesome, awesome. That means nothing. Other than the fact that, yeah, you can, if you accept 50 Hz, you accept the lowest common denominator for 50 Hz. Yeah, but what's the weird thing with the 50 Hz? I guess that's tough luck because you're all in America. You're all in NTSC land because, well, in Europe you would never find something that doesn't support 50 Hz. I don't think so. At least it would be very strange because well, a lot of stuff just defaults to 60 anyways. But a lot of like the sports broadcasts, they're still in 50 Hz. And if you convert that to 60 Hz, it will be juddery and awful. So obviously, because sports is very important, Fußball ist König und so, they still have 50 Hz modes specifically for that, even on your like IPTV boxes or whatever. Specifically so that the funny black and white ball is in as high definition as possible. Even though all the TV channels have like terrible bitrate and you can't make anything out anyways. It's gotta be smooth.
So
but
480i can be signaled at 27 megahertz, which would mean 270 on HDMI.
480i, you're saying that? Yeah, the 480i is
480i, yeah.
that one's weird because if you were to send that normally, it would go under the 250 megahertz.
Oh, and a lot of things will reject anything under 250 megahertz.
So what you have to do is actually have to make it 1280 wide or like double wide.
Yeah.
And then you can get it, and that's kind of, this really messes with the capture card that I have. I have a box that does 480i over HDMI. And it really hates that 1280 by 240 sort of frame that comes through. Or is it like 1440 by 240? I don't remember. But it's very large and it's very wide and very narrow. It doesn't really like that one at all. And this doesn't really give any bandwidth advantages that doing 480p wouldn't. On the HDMI side, of course, you can fetch the video source data at half rate. But what's that going to buy you? But yeah, you could try for like 720 by 576 50 Hz. That's the PAL mode. That's at least slightly nicer than what you get on actually it's more than 540 lines, right? That's 567 many lines anyways. 576. The old numbers making me trip up. That should be at least a vaguely standard mode that anything that isn't just generally annoying wouldn't reject. The problem is that that's not a wide mode. I'm not sure if you can make a wide mode out of that. but they don't have wide modes for the low res stuff generally.
Mhm.
They just kind of, it's because of course if you have like if you remember like DVDs, right? They're not really widescreen either. They're just 640 by 480 or like 720 by 480. I don't remember how it is. But when the flag says it's 16 by 9, it just stretches it out.
Right.
Which is, yeah, it just does that. So they don't never specified square pixel widescreen modes that are also low resolution. I mean, the ostensibly least bad solution is to just start out in 640 by 480 and then like pop up a menu or like some other sort of configuration that you put on the SD card. Select the mode you want to go. If you can only do 480, then like okay. If you can do like crazy quarter HD, then yeah, you can do that. But then you have to design whatever goes on the screen to sort of resize a little bit. Which is probably a good idea anyways, if you want to have like two editors side by side or something. Then you need to resize anyways. That's kind of a whole thing. And you know, I've been staying in the 480p funny safe zone, right? Because all the stuff I'm doing is just
Kind of legacy.
yeah, it's legacy enough that it's all 240 lines that I then double up to 480 and it's all fine. I don't think if I even have a non-line doubling version. I mean, I could easily make one, but right now I have one that doesn't pixel double for the SNES emulator. And that sort of simplifies the whole thing a lot. Because remember, if you want to have two of each pixel sent twice, you have to do it in software, right?
Mhm.
And I made that happen alongside the audio. Which was very funny to do. But actually works, and yeah, it actually works. And it doesn't require any extra components.
Huh, they have some things that are signaled at 27 megapixels at 270 megahertz for us. They have a 1440 by 480i. That's 27 megahertz.
Yeah, that's the 480i mode I was talking about. All the lower resolution 480i modes are just that mode, but with a special flag set that's actually the low resolution mode. So it doesn't try to scale it and then it becomes blocky. But that is a real video mode.
Well, if we could get that data sheet for that Chinese chip, we could spend 7 pins and get all the way up to 1080p.
Yeah, but be noisy.
Well, I have some converters that are better than others, and I think that they're probably skimping on bypass caps and things like that. But I have some that work great, and one that's like kind of grainy. But I think it's a noise problem because of a poor design.
Well, they also say they have you can also do the 1440 by 576, which is sort of almost.
That's a 50 hertz mode.
Yeah, it's a 50 hertz mode. But the question is, how uncommon is it for 60 hertz only devices to exist these days?
Mm-hmm.
I'm sorry, Chip, you're still looking for that the data sheet on that MS9288 Alpha?
Yeah, well, I found the data sheet, but it was in Chinese, and then
Yeah, I saw that. I'm trying to dig. I'll figure it out. If I find it, I'll let you know.
okay.
Okay.
Well,
I'm interested.
I had Chat GPT here translating parts of it and also scouring around for what people have discovered, but they don't have any, it doesn't have any concrete data about what the registers are and what they do. They say they have like these functional descriptions, but you don't know what register it is in the I2C thing and how it actually all works.
I mean, the funny part would of course be to just find one that has the external MCU used, hook up the I2C, and then just figure out, yeah, what's
watch it.
sending down the wire.
Right.
And then you can sort of reverse engineer what the commands mean by trying to do your own thing.
Yeah, I mean that converter I have, it's set up, it's just for YPBPR or components. So I think
it has to know that somewhere.
Yeah.
Unless it's very funny and just decides that based on, like, try one of the VGA converters, but send the component signal in. It might just decide that based on whether it's getting separate sync or if it's getting sync on green.
Yeah, this was sync on green.
Yeah, but if you sync on green, does it then think it's a component video signal?
Oh yeah, maybe it makes a decision then. But all it had was 3 inputs. It just had the Y, PB, and PR inputs.
Yeah, but it still has the HV sync on the chip, right? If you hook something up to that, would it then think that it's a VGA signal?
Oh, right.
Like it's like sort of inferring the video format from the sync source, because actual sync on green RGB is very rare.
Right. Well, I think
Interesting enough, the monitor they've got does apparently do sync on green.
the chip must recognize that when it runs, because the sync is so critical to get right down to the picosecond that you can't be interpreting that with some other third party. You know, the chip would have to be able to pull sync on green.
Yeah, but it has to decide whether it's taking external sync or sync on green, right?
Mm-hmm. Well,
and when it makes that decision, it could infer the color format from that.
Yeah. Yes. I wish they just made these monitors so that they had a mode where you could just say, just change this part of the screen, or some drawing primitives, you know, or let me buffer up some like stuff and then tell you when to show it. That'd be really nice.
Yeah, but they need to have all the processing on the monitor.
Well, the monitor today has that anyway. It's got plenty of buffering. I mean, even if you could just rewrite.
Actually, I don't know how much buffers the average monitor has, because that's kind of a lot of memory, potentially.
Yeah, but it's so cheap these days that.
Yeah, the thing is that that buffering it would also be unnecessary to some extent, because what you really want is to send the data straight out to the pixels, right?
Yeah, but they do like
buffer it.
They do multi-frame resolution enhancement today. They do all kinds of stuff.
They do it on a TV, yes, and then on TVs they do have that stuff, but everyone hates it because it makes the latency go higher.
Right. But
it also makes your video look weird.
And it's all in the cheap chipsets that they build the TVs out of. So it's kind of like for free. It's to the point where you probably can't even get away from it. But I think the game mode is to cut down on that processing and just
if they have a game mode, then that's specifically to turn some of that stuff off sort of automatically. They've also invented like a way to tell the TV over the HDMI signal that, hey, please turn off the bullshit. We want the gaming.
Right.
interesting secret feature that a lot of TVs have from a lot of different brands. I don't know why they do this, but they have this capability to like say, okay, this input is my VCR, this input is my whatever, this input is my PC. Now, if you set that input to be PC and send the right kind of video signal that it likes, it will actually switch into a special PC mode. I've never seen this documented anywhere, but it's real. And this special PC mode has no overscan, and it usually doesn't have any of the processing, because doing that to like text will not result in any good, especially if it's like the chroma subsample text, right?
Right.
And that's a secret feature that most TVs have.
Yes.
And it's like very weird because no one tells you about it. You just need to use that input rename function that they all for some reason have, even though it's kind of silly. Like, yeah, I don't remember what's on my HDMI port, please. I need to label them on the OSD.
Mm-hmm.
Well, it's better than just having fixed names for them, like most of these AV receiver amplifier things do. Because then you have to remember which one is which of those predefined input names. Oh, okay, I have to press the button that says satellite, because that's where my Wii is connected. Like that's kind of more mental load than if they just called it input 3, input 4, input 6, input, you know?
Mm-hmm.
And then they've got weird restrictions on which input can do what. Like some inputs have a record out, some inputs I think only the DVD input can do the like discrete analog, at least on the one that I have on the Pioneer box. Very strange things that happen with these. And I still want to get one of those stupid discrete 5.1 boxes. I did find one, but it costs like €100. Like, why is it this expensive for like a weird Chinese box? But it has a USB input, which is kind of interesting. Wait, it also has a USB on the front. What the fuck is this doing? USB to 5? What?
All right,
Oh,
ChatGPT.
I get it. I get it. They could plug a USB drive into this, and this will somehow play it using the 2 buttons that you get. Yeah, now I get why it's expensive. It can play for fucking files from disks. But I just want a box that can give me my HDMI audio, because then I could mess with the multi-channel stuff.
Yes.
But oh no, I cannot.
Why can you not?
Because they're all expensive, and I don't have one that takes multi-channel PCM directly. I mean, what I could do is figure out like an accessory board that just has 6 RCAs on it and wire that directly into the discrete out. But that's a wiring nightmare.
What about like Toslink or something, one of those like digital audio?
We had that earlier. Basically, they never specified multi-channel over SPDIF, so it doesn't exist. The bandwidth is there, it just doesn't do it.
So how many channels do they do? 5 channels over Toslink or something?
You can do 2 channels. Technically, there's some sort of vague capability to do 4, but I don't think anyone supports that. You certainly can't do the 6 that you need for like the regular 5.1 stuff.
Yeah.
Again, you could do it in terms of the bandwidth that you can push over the cable. It just never formalized the format to do it, so no one does this. We're getting some real Chinesium stuff in the beats here, but I just want
Hey, guys, I'm working on it. I might get something or an
I
equivalent.
just want box that does not have
So ChatGPT wrote a nice letter requesting, saying that we're working on our project and we would like technical
I wouldn't do
information.
that.
Now I'm filling out the specifics and I'm going to mail it to them.
That's not a good idea. They won't like that. At least I wouldn't like it if I get like weird AI slop in my
Well,
mailbox.
I don't know that it's AI slop. It looks pretty good.
Nah, it's definitionally it's like if you touch the poo with your hand, if you don't wash it afterwards, you've got the poo hand, even if it doesn't smell.
Let's see. Well, I'm going through and
that's the-
editing it and simplifying it.
Or maybe check the
Hey, Werfel, Ada, what's the you're saying 11 channel? Is this
11 channel what?
11 channel audio? Is that got a Dolby, like is it Dolby 7.1.4?
Yeah, something like that, yeah.
Right.
If you've got something like that on your amplifier box, there's no way to feed a raw PCM version of that into it, or even a raw analog version. You can only do it using the Dolby bitstream or the DTS bitstream or whatever.
Right.
You cannot do it just with, or you can like let it up convert what you're feeding in, which that can work. It's not terrible. Well, of course, I mean they can even do it with a regular stereo source. That's kind of like squeezing blood from a stone. Like getting 11 channels from just 2. Somehow they claim to be able to do it. I've not heard it. Like getting 4 channels, like okay, hey, we're getting the center channel and we're getting 1 back channel. That's already kind of hard to do it without a lot of bleed. But you can see how it's done by just having a bunch of VCAs that react to like the signal characteristic, blah blah blah. But then they just keep going. And now we've got where do you get the height channel from, like a stereo signal? It's probably using some sort of heuristic based on the idea, okay, stuff that's from the top sounds brighter. You might have noticed that's stuff that's above you sounds very bright. And you can see that with all the like if you look at the spectrogram, if you have like one of those 3D audio things, if you move the source to the top, it just gets a lot of that like really high end. And presumably they're working off of that cue. Very interesting. But it doesn't let you really, I don't think they've got specific encoding like they used to, because for the plain Dolby Pro logic, you could actually encode your signal in a particular way and would do its best to restore that back out. Because with putting something in the center, just put it into left and right without any phase difference. It can't distinguish between that and just putting it on the left and right separately, but that's mostly good enough for like a usual movie soundtrack kind of thing.
Yeah. There's a place here. Somebody spent an awful lot of money setting up a place called the Synth Temple. You know, you can like rent a synthesizer or a recording studio, but they seem to list, you know, the Dolby 7.1.4 or 9.1.6 systems and things like that. Like you say, you can't interface to them. It's like got to be some kind of
Well, if they have it set up like this, they probably just have like a PC with an amplifier or something.
yeah.
Like just multi-channel from a PC out or something. Or from like a proper mixer or something. That you can do, of course, because it's just a lot of speakers. But if you have that, you cannot play your movies on that.
No.
Because you need to somehow decode the bit stream into the discrete channel, right? To make that happen. And that's what the box can do. But the box cannot take discrete PCM. That's a very interesting thing that I've kind of stumbled upon. If you want to like master this stuff for distribution as this Dolby bit stream, you have to set up like a regular multi-channel thing that just goes out of your computer, but that will not be able to listen to the actual result. You can only listen to your master file. And then you send that to like wherever, they encode it into the bit stream. And then you cannot listen to that bit stream on that setup. You have to have a separate setup to listen to the bit stream. Yeah, it just does that. That was no, I let's see if I'm any luckier with finding stupid HDMI audio boxes on AliExpress.
Yeah.
That's the source. That's where you can find the real good stuff. It's some frankly ridiculous things. But nah, they only want to give me the stereo ones. I want the ones with absurd amounts of audio jacks on the back.
Just start your own system, Ada. It's going to be quicker.
Frankly, that's kind of would have been smart anyways in my own system. I mean, just revive one from like the 70s. They have ever heard of ambisonics?
No.
That's like basically they invented something that's way better than in theory but also way simpler than the old surround sound standards we have, because it's like inherently extensible and based on mathematics. So basically you just encode like the direction that the sounds come from on like a sphere. And for the basic version, it only needs 4 channels, but that's full 3D already. But it's kind of like, it doesn't have a lot of spatial resolution. So you can add more and more layers on top of that to make it even more precise. And because it's mathematics, right, you can't just sell a new product. It's always backwards compatible. You can just cut out the higher channels and then you've got the basic version again.
Yeah. It looks good. Looks like our kind of deep dive.
Yeah, it's very interesting. The problem is that nothing supports it. They sold a few hardware boxes in like the 70s, 80s in Britain. And that's basically that. And a lot of that is basically just it's basically limited to UHJ, which is like the stereo encoded form. Which is even less of a thing. Well, I can find a 6-channel I can find a 6-channel analog box. But I don't know if, because if they want to be cruel, and of course always these Chinese guys are always very cruel, they could make one that doesn't work with PCM. Because it doesn't say PCM anywhere. Extremely poorly translated descriptions. But I need you to tell me. I need the box to make to make me happy. Because then I could futz around with like the HDMI multi-channel stuff, which is very interesting. Because what I've sort of weirdly concocted in my mind is the idea that if I make something that renders into like a agnostic format, like maybe Ambisonics, then I could have the video driver, which kind of doesn't have anything useful to do anyways during blanking. That could maybe do the mix conversion to like an arbitrary channel layout. And then I could have my application code just render the same thing always, but then the video driver decides what kind of output I get, and I could get a 5.1 output from that. And that just plugs in and works. If you have a thing that actually supports that, which, you know.
So I sent a very nice clean letter off to Macro Silicon requesting more information on that chip, and I expressed that we're happy to sign an NDA, and our goal is to just take YPBPR and left-right audio and generate a 1080p HDMI signal. We'll see what they say.
The HDMI might be the hang-up point, like if you're specifying you want HDMI versus DVI, or, you know.
Oh, well, what does that thing say? I mean, what claim does it make? What does it say it does?
Like Ada pointed out, they just call it HD transmitter. And I looked at Analog Devices stuff, and they also just refer to an HD transmitter.
Oh, okay.
Hey guys, I appreciate your time and I learned a lot. Thank you very much. I got my contact with Mauser. They're stuck with the Chinese stuff and they're trying to find enough information to cross it to something else, and they'll let me know.
Cool.
So, and I got to do some honeydews. So always, Chip, is a pleasure.
Likewise. Thanks, Martin.
Hey, you know, and Ada, you're cool. I like you. And the guy from Australia, hey, pretty cool stuff. I really enjoyed it. So
Thanks,
y'all have a good day.
Thank you very much.
Okay.
You too.
Bye-bye.
Bye-bye.
So did you send the letter, Chip? You already sent it?
I hit send. Yeah, but they're probably going to tell me, well, we don't do HD, HDMI, or they'll say HDMI very difficult.
Very difficult.
We'll see.
I mean, technically, I could just do something very silly and plug 2 AV boards into one P2 breakout. And then I get 8 channels of analog, which doesn't help with the idea of doing it over doing digital PCM output, but that would solve the annoying part of getting the whole thing up and running in the first place.
Well, shall we shut the meeting down?
Yeah, but get back to me on the
Oh,
like,
yeah.
Cordic thing.
Yeah. Okay. Ada, tell me again, what you wanted to know was there something about, was it vector mode or?
Basically all the modes I'd be interested in. I figured the exponent and logarithm modes, but those only have one input, so it's kind of easy to figure that
Oh,
out.
yeah.
Also, they're like
Okay.
quasi documented in the code, so
Right. Okay. Very good. All right. Well, guys, thanks all for coming today.
It's good.
And hopefully we'll see you in a month. And thanks for presenting that stuff, Lachlan. That was really neat.
No problem. Good to get it presented, then you sort of tidy it up and move on to the next thing.
Yes.
I got to talk to Roger, see what he can talk about with that chip.
Yeah. Well, apparently there's a bunch of I2C registers that just need to be set up, and who knows, maybe they'll get back to me. Maybe you'll have something like in an hour. I mean, what time is it there? Is it Thursday morning? They're 16 hours ahead, right?
Yeah, it's a few hours ago in Thursday morning, so early Thursday morning.
Yeah. All right. Okay. Well, you guys all take care, and thanks for being here today. And we will see you soon.
Okay, see ya.
Okay. Bye-bye.